Good evening, Professor. This is my personal timetable. So, before to start my personal timetable, I just want to brief my weekly plan. So, my weekly plan is like to work onto the BATIO3 chip. So, it's basically it's a chip having the pore size onto the surface because of this material, and we have total 7 chip. So I have checked that the 2 chip circuit already broken, so we have only 5 chip to work on that. So before to use the BATIO3 chip, so I have to just go through with the normal chip with our research plan. So our research plan, this one, and we just only use the normal P6 chip first, and for checking this whole step is working onto the BATIO3 or not by using the capacitance measurement. So if step 1 is like Ag nanoparticle onto the surface and rinsing with PBS, and afterwards we use MUA onto the surface and immobilization of EDCNHS, washing with the ethanol, and afterwards immobilization of antibody onto the surface, blocking with the BSA and washing with the PBS, and afterwards we use antigen, and the same is like washing with the PBS to check the capacitance value with respect to the antigen concentration. So this is the schematic overview that we have to follow. In this case, onto of BATIO3 chip, we don't have to do the piranha cleaning because we use the piranha is acidic solution. So if we use that one, so all the BATIO3 layer peel out from the surface. We have to just skip this one. And first we have only the Ag nanoparticle immobilization, washing with the PBS, and then afterwards MUA nanoparticle immobilization, and afterwards MUA we use EDCNHS. Here why we are using MUA, because MUAs act like a cross linker, and then afterwards MUA we use EDCNHS cross linker again to bind with the antibody, and then afterwards BSA, and then antigen, and washing with the PBS. So this is the whole schematic overview that we have to follow onto the BATIO3 chip. So before to use the BATIO3 chip, we have to just go through the same process onto the normal chip, whether this process is good or bad, or like we are going in the right direction or not. So because why we are doing this, because we have the only 5 BATIO3 chip. So without wasting our BATIO3 chip, we have to just go through first onto the normal chip. So from the last week, I did some experiment in 4 different cases, like which step is more feasible for our chip. So first case is like here we use Ag nanoparticle having the 10 nanometer particle size, and then step 3 is like rinsing with PBS, and again we use MUA, and then afterwards EDCNHS, washing with the ethanol, immobilization of antibody, blocking with BSA. So this is the process that we have to use on this case. In this case we use 8 chip, 8 P6 chip, and first 4 chip I use new antibody, and the last 4 chip I use amyloid beta antibody to check whether the antibody problem or what. So I found that there is no antibody problem. first, and the second one is like here we use nanoparticle, so that's why the result are more stable. And if we use this case onto the BATI3, so the efficacy of the process is more stronger and more stable because of the presence of the nanoparticle. And as we know that BATI3 having the pores onto the surface, so it's greater chances to the getting the positive feedback from this research plan. And also BATI3 we use as an anchor sites, so it might be getting chances of this AG nanoparticle stuck onto the pore, and then afterwards the whole things are just get into with the AG nanoparticle. So before to explain my result analysis, first go with the result what I got. So the first, as I already told, that I use 8 chip. First 4 chip I use new antibody, and the last 4 chip I use amyloid beta. So the first 4 chip I got up to the antibody is nanofarad value 1.30, 1.54, 1.26 and 1.36 nanofarad. This one is the new antibody results, and this one is the amyloid beta results. So the result is stable. And why we got the lesser value of new antibody? Because the concentration is less. Its concentration is like 0.9 microgram per ml, and for amyloid beta case we have 1 microgram. So because of the concentration, I think that the value is much lower, not much lower, is lower than the amyloid beta because of the lower concentration. Otherwise the value is stable and there is no problem until now. So because of how we can get the stable results, because of the AG nanoparticle onto the surface. So if we use this case onto the BATI3, it might be getting the good results. So here the result analysis, we use 8 chips, 4 for new antibody and 4 for amyloid beta. According to these results, we got the higher value of capacitance of amyloid beta as compared to new one because of the 0.1 less concentration, and also the efficacy of amyloid beta is more than the new antibody. And in this case, AG nanoparticle plays a major role, and it's a linear deposition method or linear deposition onto the surface, and it's a drop casting method that we had followed. So this is the result analysis of this case, and until now we got the better results. And if we so the second case is the different one. Second case is like I use here new material, new particle, is a gold nanoparticle. We have this nanoparticle in our lab, so I just think about like if we use gold, like then how it works and how we can combine with our research. So I just use the gold nanoparticle in place of the AG nanoparticle, and using the same process, but here I didn't use MUA. I just directly go with the EDCNHS. I just skip the MUA part. So I just want to I have to just curious about like how it works and how we can combine and what is the value if we use this gold nanoparticle. So first of all, I just want to go show you the results. So the result is much higher value than the case first. We got the nanofarad value is like 11.2, 10.8, 11, 8.89. I think I have to repeat this again experiment to get the more stable value, because the 4 chip is not working well as compared to 3 chip. So I have to repeat this again for double check, or like you can say getting the stable results. So if we go with the result analysis, the gold nanoparticle is major role because of the conductivity, or you can say the um, stability is much higher than the AG nanoparticle. So here we didn't use MUA, we use gold nanoparticle onto the surface. and the drop casting is acceptable for this experiment. So we got these results. But in the case 3 is the different one. Here we use all MUA with the gold. In the case 2 we didn't use MUA, but in the case 3 I just used the MUA to know MU is tuned the whole process or not. So I found that the MU is also having the role to uh, get the direction of this process. So I found that the gold nanoparticle is bind with the MUA and then MUA bind with the EDC. So in this case also, in case 2, case 3 and case 4 also, I use the amyloid beta antibody, not using the new antibody for this process. So because of the gold nanoparticle as compared to the Ag nanoparticle, the value is more stable, and the value also getting stable as compared to the case 1, because in the case 1 we got the 1 point something nanofarad, but in this case if you can see here, I use only 2 chip for this case, so we got the 3.50 nanofarad and 3.43 nanofarad. The value is clearly stable and not so much difference. So I have to repeat this again process to double check this whole experiment, and also using the 5 or 6 P6 chip, not the 2. So I use only 2 because of just double check other gold nanoparticle is working with the MU or not. So this one is the result. Until now, case 3 and case 1 is my main thing to go with that, and it's a case 4 is like I'm just having the curiosity to check if we use the both nanoparticle together and using the EDCNHS, then how it works. So I found that there is no as such a positive feedback from this case, because if we use Ag nanoparticle and gold and directly with EDCNHS, it might be getting the not more getting the stable result, because if you can say if we use the other things like if we use MUA here, then it might be getting, but until on this case I just use only Ag nanoparticle, gold nanoparticle, EDCNHS, and then again and after that antibody. So here in this case also I use only 2 P6 chip, and the result is higher than the case 1. In the case 1 I use only Ag nanoparticle, but in this case Ag and gold together. So that's why we got the high results as compared to case 1. And of course gold nanoparticle plays a major role for this case, and in this process we use Ag, gold bind with EDCNHS, not MUA in this case. So the result is not stable, maybe because of the EDC is not easily bind with the gold nanoparticle, because there is no as such bond onto the surface combined with the gold or MU like EDCNHS. So this case also I have to repeat this again with the MUA, not without MUA. It's like I have make a plan for this week or next week, until this next week, using the 3 main cases again for double check the whole case, the all cases. So my next plan is first is like Ag nanoparticle and then MUA and EDC. I have to do this case again for double check. In this case I use gold nanoparticle and MUA and EDCNHS. This one also I have to repeat this again, because previously I just only used 2 chip, and before to use the BATIO3 chip I have to double check which process is more stable. So without wasting our time, I just have to deal with all cases in a short period of time. So that's why I just make a plan here, and I have to finish in this week anyhow. So in this case only I use only AG. In this case also I use gold, and in this case I use AG and gold with MUA. So these three cases I have to do it again, and in this week I have to finish this whole process and deliver you the result, and hopefully we will get the positive result, and soon to find which case is more suitable for our BATI3 chip. So BATI3 pore is 8 to 10 micrometer pore size, and our gold nanoparticle is 3 nanometer, and AG nanoparticle is 10 nanometer. So it's easily stuck in between the pores, and we got the stable value. So this is my plan for tomorrow onwards, and until now I have to just find out which process is more stable. So these three cases I have to follow up in this week, and once I will get the results, let you know, sir. That's all, sir. Thank you.